In the heart of the battlefield, where dominance is measured by speed, armor, and firepower, a machine was born that redefined the philosophy of modern armored warfare, the M1A2 Abrams. It is not merely a vehicle made of steel, fuel, and ammunition. It is a living system of layered armor, turbine power, digital sensors, and fire control that together determine who survives and who falls in the chaos of modern war. To understand the Abrams, we must go back to its origins. During the 1970s, the world was witnessing a rapid evolution in Soviet tank design, faster, better armored, and equipped with powerful new guns. The United States needed an answer, a tank that would dominate the Cold War battlefield of Europe and beyond. The response was the M1 Abrams, an entirely new concept in armored design, combining unmatched protection, superior firepower, and high mobility. Over decades, it evolved through multiple generations, culminating in the M1A2 and its advanced variants like the SCP-V2 and SCP-V3, each iteration more lethal, smarter, and better connected than the one before. Traditional tanks relied on thick steel alone. Abrams took a different approach. Composite armor, a revolutionary system that blends steel, ceramics, and advanced materials to absorb and deflect kinetic and chemical energy. Some variants also feature reactive armor tiles that explode outward to neutralize the impact of incoming anti-tank munitions. This design not only prevents penetration but disperses the destructive force of explosions, drastically improving the crew's chances of survival. At the heart of the Abrams lies something even more unique, a gas turbine engine, the AGT-1500. Unlike conventional diesel engines, this power plant is a jet engine adapted for land use. It delivers tremendous horsepower and acceleration, allowing the Abrams to reach and maneuver at high speeds despite its enormous weight. The turbine burns jet fuel, giving the tank a high power-to-weight ratio but also demanding careful logistics and high fuel consumption. Yet the payoff is a tank that can surge forward, reposition rapidly, and react faster than almost any heavy armored vehicle ever built. The soul of the Abrams, however, is its 120mm M256 smoothbore cannon, a weapon of precision and power. Developed through American and German collaboration, it fires a range of advanced munitions. Armor-piercing, fin-stabilized, discarding sabot rounds, APFSDS, high-explosive anti-tank rounds, and multi-purpose programmable shells. Combined with a computerized fire control system, stabilization gyros, and atmospheric sensors, the Abrams can fire accurately even while on the move. In modern tank warfare, that precision often decides the difference between victory and destruction, but the Abrams doesn't rely on its gun alone. Its fire control and targeting systems form one of the most advanced suites ever installed in a ground vehicle. Thermal imaging sights for the commander and gunner allow the crew to detect and engage targets day or night, through smoke, fog, or dust. Digital sensors feed data into a ballistic computer that automatically calculates the ideal firing solution, considering range, wind, barrel temperature, and target motion. In a split second, the system determines where to aim, and the round hits with deadly accuracy. This digital brain extends beyond the gun. Modern M1A2 variants feature network battlefield connectivity, linking every Abrams with command centers, drones, and friendly units. Each tank becomes part of a massive digital web of information, sharing real-time data, spotting targets, and receiving mission updates. This concept, called network-centric warfare, transforms every Abrams from an isolated tank into a mobile node of battlefield intelligence. Inside the tank, the crew operates as a single organism. For men, commander, gunner, loader, and driver, each trained to perfection, synchronize their movements under immense stress. Training for the Abrams is among the most demanding in the world, requiring mastery of fire control systems, maintenance procedures, turbine management, and battlefield communications. Because in the Abrams, survival and victory depend not just on steel, but on teamwork and skill. Safety systems play a vital role as well. Automatic fire suppression systems, blast-proof compartments, and fuel cells designed to resist explosions protect the crew from internal and external threats. The interior is lined with spall liners, material that absorbs shrapnel from penetrations. Even the ammunition storage compartment is separated by armored doors and equipped with blow-off panels that vent explosions upward, away from the crew. The Abrams has proven itself repeatedly on the battlefield. From the sands of Iraq to the plains of Europe, it has demonstrated unmatched survivability and firepower. In open combat, its ability to engage enemy armor from long distances, strike accurately on the move, and withstand direct hits has made it the backbone of U.S. armored forces. But war is not only about strength, it's also about adaptability. The Abrams' performance in asymmetric warfare, urban environments, ambush zones, and counterinsurgency missions taught valuable lessons about mobility, communication, and integration with air and infantry units that, of course, no machine is perfect. The turbine engine, while powerful, runs hot, creating a large thermal signature visible to infrared sensors and drones. Its fuel consumption is heavy, limiting operational range and requiring an extensive logistics chain. The tank's massive weight, around 70 tons, also makes transport and bridge crossings a challenge. Still, for its intended mission, frontline dominance and survivability, the Abrams remains a masterclass in modern armored design that on the tactical level, Abrams units serve not only as offensive punch, but as instruments of deterrence. The mere presence of an Abrams battalion on the battlefield changes the enemy's calculations. It represents firepower, protection, and psychological dominance. Its roar, the dust cloud it leaves behind, the unmistakable silhouette of its turret, all project power long before the first round is fired. Modern upgrades continue to push the Abrams into the future. The M1A2 SCP-V3 and V4 incorporate next-generation electronics, improved armor packages, and active protection systems, APS, smart defenses that detect and intercept incoming missiles before they strike. Improved battlefield sensors, thermal imagers, and integrated communication networks turn the tank into a hub of information as much as a weapon of destruction. Future variants may include hybrid engines, artificial intelligence-assisted targeting, and drone integration, creating an ecosystem of manned and unmanned vehicles working in harmony. Yet maintaining the Abrams' combat readiness is a challenge of its own. Its cost, millions per unit, means it depends heavily on efficient logistics, spare parts, trained technicians, and specialized maintenance facilities. A tank is only as effective as the supply line behind it. Armies have learned that sustaining these complex systems under field conditions requires not just engineers and mechanics, but a disciplined chain of support that can move fuel, ammunition, and data at the same pace as the tanks themselves. The Abrams' evolution has also led to field innovations. Crews have adapted their tanks with anti-drone systems, additional cameras, and external cages to protect against top-attack munitions. Some units deploy small reconnaissance drones alongside the tank, using aerial eyes to spot threats beyond line of sight. This fusion of armor and intelligence gathering marks the next stage of ground warfare. Life inside an Abrams is not easy. The heat, vibration, and confinement push the human body and mind to their limits. Crews operate for long hours, often in silence, relying on discipline and mutual trust. Modern training programs now include not only technical proficiency, but psychological endurance and stress management. Because inside that metal beast, human resilience remains the most important armor of all. Looking toward the future, the Abrams will face new kinds of enemies: robotic vehicles, swarming drones, AI-driven targeting systems. But rather than becoming obsolete, the Abrams is evolving, adapting to the digital battlefield, incorporating sensors and automation, while retaining what made it great: protection, firepower, and the human decision at its core. Imagine a future battle where Abrams tanks coordinate in real time with drone fleets, electronic warfare units, and cyber defense networks, a true fusion of machine and intelligence. And yet, amid all the technological progress, one truth remains unchanged: war is still fought by people. No matter how advanced the Abrams becomes, its effectiveness depends on the courage, skill, and unity of its crew. Without them, even the most powerful tank is nothing more than lifeless steel. The M1A2 Abrams stands as a monument to engineering and strategy, a synthesis of decades of experience, innovation, and adaptation. Every component, From its turbine engine to its digital brain, from its composite armor to its networked communication systems, represents a belief. That ground dominance in modern warfare is not just about brute strength. It's about balance, precision, and information. Human factors remain central. Crews operate in cramped, claustrophobic environments under fatigue and stress. Training regimens have evolved to include cognitive resilience, decision-making under pressure, and simulated stressors that mimic combat conditions. Crew drills for hull breaches, partial system failures, and casualty evacuation are as critical as live-fire exercises. Many tankers speak of the informal skills, listening for a strange bearing, feeling a shift in engine tone, that machines cannot replace. The human element remains the decisive factor in survival and success. The Abrams story is also geopolitical. Its deployment signals commitment, whether in NATO exercises, show of force missions, or coalition operations. Export and alliance politics shape which variants operate with partner nations, and interoperability requirements force manufacturers to conform to alliance standards. This diplomacy of metal and logistics ensures that the Abrams is not merely an American weapon. It is often the centerpiece of multinational deterrent strategies and interoperability exercises. Economic and industrial realities are inseparable from the tank's existence. Producing and upgrading Abrams requires a complex industrial base, specialized foundries for armor components, suppliers for electronics, and skilled labor to assemble intricate systems. Budget decisions determine cadence of upgrades, procurement numbers, and depot modernization. The balance between buying new platforms and modernizing existing fleets is a strategic choice, reflecting how nations prioritize readiness, technological edge, and fiscal constraints. Field adaptations reveal the ingenuity of crews and units. In theaters of asymmetric conflict, crews have added extra cameras, improvised armor kits, and mounted commercial sensors to detect threats. Some units outfitted Abrams with cage or slat armor to defeat shaped charges. Others added heat dissipation measures to mask the vehicle's signature. These field-level modifications underscore a timeless truth. Technology and doctrine are only complete when tempered by the resourcefulness of those who operate them. As we look outward, we must consider the ethics of armored power. Tanks are instruments of decisive force, but they operate in human landscapes, cities, villages, and places where civilians live. Rules of engagement, target discrimination, and efforts to minimize collateral damage shape how commanders employ the Abrams. Precision is a moral as well as a tactical imperative. The introduction of programmable munitions that can select effects reduces indiscriminate harm, but it does not remove the need for careful, disciplined command decisions. The future of the Abrams will be written in lines of code, sensor arrays, and new materials. Hybrid and alternative propulsion systems could reduce logistic strain and thermal signature. AI-assisted targeting and decision aids may speed the kill chain, but they must be tempered by human judgment. Modular armor and plug-and-play electronic suites will keep the platform adaptable to unforeseen threats. And as armies experiment with manned-unmanned teaming, the Abrams could become the commanding node of a ground combat system that blends human insight with robotic precision. Ultimately, the story of the M1A2 Abrams is a story of balance. It is a machine born of compromise between mobility and protection, between firepower and logistics, between human skill and automated systems. Each upgrade, each tactical adaptation, each lesson learned in the field has been an answer to a shortcoming or a threat. The Abrams did not become a legend because it was perfect. It became a legend because it adapted, because it was supported, and because it placed human crews at its core. In the end, the Abrams is more than metal and electronics. It is a symbol of engineering ambition and doctrinal thinking, an artifact that embodies the belief that control of the ground matters. It is the product of a complex ecosystem, designers, engineers, soldiers, logisticians, and nations, that together produce combat power. And for all its systems and sensors, it still comes down to people. Crews who train, maintain, and maneuver under pressure, and commanders who commit them to battle with grave responsibility. As the sun sets over training grounds and deserts alike, the Abrams silhouette remains a reminder of an era where armored power shapes strategy and politics. It is a machine of the present, and yet a platform poised for an uncertain future, one where the lines between man, machine, and algorithm will only continue to blur. The M1A2 Abrams has adapted to survive, and as threats evolve, so too will the ideas and innovations that keep it relevant. If the measure of a platform is not only how it fights, but how it endures, then Abrams endures because it was designed to change. It is a living program, updated in workshops and labs, tested in exercises and combat, and defended by the men and women who keep it running. In the broad arc of military history, the M1A2 stands as a testament to the relentless pursuit of superiority and to the enduring truth that technology, when partnered with trained people and thoughtful doctrine, shapes the outcome of battles and, sometimes, the fate of nations.